critical values. For the standard normal distribution, a critical value is a z-score on the borderline separating those z-scores that are significantly high or low from those that are not significant. So remember here that a critical value is a z-score, and those are things that we've already have some experience with. Now, the number z with a subscript of alpha divided by 2 separates an area of alpha divided by 2 in the right tail of the standard normal distribution. If you recall, when we had z subscript alpha, it was always the area in the right. Now, z alpha divided by 2 again separates an area of alpha divided by 2 in the right tail of the standard normal distribution. So this is what you're looking at. Okay, so for example, okay, let's say that we wanted to find 99% confidence. Okay, well, instead of that, let's do 99% confidence. Okay, so in order to find alpha, okay, so let's say it's 99% confidence, and let's say alpha, okay, is going to equal 1 minus 0.99, and that gives us 0.01. And then what we're going to do is we're going to take alpha and then divide that by 2. So we get alpha to be 0.01, and then we divide that by 2. Well, if we divide that by 2, we get 0.005, which means that this area would represent 0.005, and then this area over here would also equal 0.005. Now again, we want to find the z-score on the right because it says in the right tail. Now if you notice, here's 0, and on this side would be the negative z-score, but here we are only concerned with the positive z-score because it's in the right tail. Okay, so let's take a look at what's happening here. All right, so in this area here, okay, in the middle, in this middle section here, okay, this is going to represent the total of 99%. Okay, and so that's going to be what we have in the middle. Now, one way of looking at this in order to find that z-score is to take the following. We would say, okay, we're going to take 1, and then we're going to subtract that alpha, which is 0.005. And then what that gives us is the following. So if we take 1 and then subtract 0.005, we get 0.9950. So we're going to get 0.9950. Okay, what that's going to represent, and I'm going to go ahead and use a color here. This is the area that's going to represent everything that's to the left of this, which includes both the 0.99, right, the 99% plus the 0.005. That's one way of finding the z-score. Now, we can also then locate what this is over here. So I'm going to show you two different ways to be able to find the positive z-score using Statcrunch. So let's open up Statcrunch. So if we have Statcrunch, I'm going to go ahead and hit refresh. Okay, we want to make sure our mean is 0 and we have 1. So if we want to find the area that's to the left of this, now remember we have 9.99 plus the 0.005, which gives us 0.9950. Then we would then put in 0.9950, and we know this is going to the left, and you're going to see what that z-score is over here. So let me go ahead and copy this so you can see this is one way of determining that positive z-score. Okay, and then we're also going to do the following. Okay, we're also going to take a look at, because we've had these different scenarios in our previous sections. Let's say we just want to take and find the area that's to the right, since we already know it's 0.005. So I'm going to come up here and I'm going to select refresh. Okay, And again, we know we have our mean of 0, standard deviation of 1. Now we're going to change this to be greater than or equal to. And now we're going to put in the area of 0.005. Now, if you notice, it's going to give us the same critical value, or that z-score. Okay, so you can see that there's two ways of going about that, but we also need to understand what is happening here, okay? Because if we use Statcrunch, right, and we want to find this right here, there's two ways to be able to do that. We need to know that if we put in the area of 0.9950, which includes everything in the middle, and this piece here, which would be 0.9950, and we're going to the left, or we can say, okay, we're only concerned about this area, so we're going to say greater than or equal to, and then 0.005, and it gives us that critical value. Now that critical value, again, is the same thing as a z-score, as we stated before. And if we round it to 2 decimal places, we end up getting 2.58. Okay? Now, we're concerned with the positive value, but this one would then be the negative version of that. So that would be negative 2.58. Okay? So, let's go down a little further here. So, we want to be able to find the critical value. Okay? So, let's use another example similarly to what we did up here. It says, if alpha is equal to 0.05, find the critical value where z alpha divided by 2 corresponding to a 95% confidence level. So note that when finding the critical z-score for a 95% confidence level, we use a cumulative left area of 0.9750 and not 0.95. So again, think of it this way. This is our confidence level, 95%. Now, what is the area in both tails? Well, the area in both tails is 0.05. And so in order to find the area in the right tail, we would take alpha, divide that by 2 to get 0.025. And then we would take 1 and subtract 0.025, which equals 0.975. So again, let's take a look at this here. Okay, very similar to what we just did before, right? We know that, again, we're looking at the 95% confidence level. Number 2, we know that to find alpha, that's equal to 1 minus 0.95, which gave us 0.05. Number 3, we want to take alpha and divide it by 2. So if we take 0.05 and then divide that by 2, that gives us 0.025. And you can see that represents the two areas on the left and the right. Okay, and then what we also want to do is, okay, well, since the middle is 95%, this is 0.95. Okay, now 0.95, if you add those two together, right, it's going to give us the following. If we take 1 and then subtract this area on the left of on the right, of 0.025, we're going to get 0.975, which basically is the following area. It's the area that represents everything to the left here, which includes both 0.025 and 0.95. Okay? And then we would also know that this area to the right over here is then going to be 0.025. Okay, now before we find the z-scores, let's just do this on Statcrunch. So I'm going to go ahead and open up Statcrunch again. Okay, I'm going to go ahead and hit Options and then select Refresh. Now again, if we want to find the area to the left, okay, we have to use 0.975. So we know that it's pointing to the left. We know we have a mean of 0 and 1. And let's put in 0.975 and then select Compute. Now you can see this matches that. And all I'm going to do now is just copy this part here that has our critical value. Okay. So you can see what the critical value is. If we round that critical value to 2 decimal places, we're going to get positive 1.96. Likewise, if we came up here, select Refresh, and now we can also find that critical value if we then change this to be greater than or equal to, and now put in this area of 0.025, then that's going to give us the same critical value of positive 1.96. Okay, so therefore now we're going to know what our critical value is. And again, the critical value is the same thing as the z-score. So we get the z-score to be 1.96, and that's the total area to the left of this boundary, which is 0.975. And again, as I stated, if this is 1.96 and we have the exact same area in both tails, then this is automatically the negative 1.96. And so therefore, there is your critical value. Now, what are some common critical values? Well, we've already seen one of them. So the previous example showed that a 95% confidence level results in a critical value of Z alpha divided by 2, which is equal to 1.96. Here are the most common critical values, and it is listed with 2 other common values in the table. So we have 90%, which is alpha, which is 0.10, and the critical value is 1.645. For 95%, we got 1.96. For 99%, to 3 decimal places, it was 2.575. Let's just go ahead and take a look at the 90%. So again, just to make sure that we see all of these, right? So if we take a look at the 90%, so again, think of the bell curve, okay? And we want to find the 90% that's in the middle, okay? So think of this in terms of, okay, step 1, we know we're looking at 90%. Okay, now what does alpha equal? Well, alpha is going to equal 1 minus 0.90, which is equal to 0.10. That's alpha. Now, if we want to find the area that's in the right over here, okay, we're going to take alpha and then divide it by 2. Well, 0.10 divided by 2 gives us 0.05. So that means that this area on the right over here and on this side is going to represent 0.05. So this is 0.05 and this is 0.05, and then what's in the middle is 90% or 0.90. Okay, so if we want to find this z-score alpha divided by 2, and then remember that this is going to be the negative z-score alpha divided by 2. So we can also look at the area if we take 1 and then subtract 0.05, which gives us 0.95. Because again, if we added these two together, we would get 0.95. So let's just confirm that, again, using Statcrunch. So again, if we want to find the area that's to the left here, we would then have to use that entire area, which is 0.95. So let's just confirm that. So here, we're going to go ahead and select refresh. Okay, we're going to go less than or equal to mean 0, 1. Now we're going to put in 0.95, and you're going to see we're going to get 1.645. Okay, and then likewise, hit refresh. If we wanted to then use the small area here, then we're going to put in the greater than or equal to, and then put in 0.05, and then that's going to give us 1.645 as well. So again, those are the common critical values.